This video accompanies learning IoT with Python and Raspberry Pi. In this lesson, we'll calculate the value of the factorial using a recursive function, and we'll use the factorial function in the calculation of the Bernoulli probability function. The value of n factorial is n times n minus 1 times n minus 2 all the way down to times 3 times 2 times 1 times 1. If n is equal to 5, then 5 factorial is 5 times 4 times 3 times 2 times 1 times 1. Now, if we look at how 5 factorial is calculated, we can see that 5 factorial is equal to 5 times 4 factorial, and that 4 factorial is equal to 4 times 3 factorial. 3 factorial is equal to 3 times 2 factorial. 2 factorial is equal to 2 times 1 factorial, and 1 factorial is equal to 1 times 0 factorial. A recursive function can be written since there is a stopping criterion of n is equal to 0, and there's a known value of 0 factorial that's equal to 1, and that's when the stopping criterion is met. And the value of n factorial can be computed, as we saw when we were computing 5 factorial, as the value of n times n minus 1 factorial. Let's go into the Thani editor and create some code to compute the value of the factorial using a recursive function. The factorial function will take a single parameter, n, and when we reach that stopping criterion where n is equal to 0, we're going to return that known value of 1. Otherwise, the function will call itself and will return n times a call to the function, factorial, passing in as an argument n minus 1. Let's create a main function where we'll call the factorial function. We'll store the return value into result after calling the factorial function and passing in a 5 for the argument. And we'll print out what the value of 5 factorial is. And we'll call the main function. Let's save this script. When we run this code, we'll see the value of 5 factorial is 120. That's 5 times 4 times 3 times 2 times 1 times 1. Let's next call the function a number of times. So we'll include a loop for I in range 20. So the values of I will be from 0 to 19, and we'll pass in I as the argument when we call the factorial function. And we'll print out the value of I and the value of result after the function call. Let's run this code. And you can see that 0 factorial is equal to 1. 1 factorial is also equal to 1. 2 factorial is equal to 2 times 1 factorial, that's 2. 3 factorial is equal to 3 times 2 factorial, and this continues all the way up to 19 factorial, which is 19 times 18 factorial. Note that the same algorithms implemented using recursive functions can often be written using loops. The factorial calculation could have been computed using a loop and accumulating the product. Factorials can be used to calculate the Bernoulli probability function. This is the calculation of the probability of obtaining a particular result. For instance, let's say you had a bin with 10 red blocks and 15 blue blocks. Let's say you wish to calculate the probability of picking out 3 red blocks in 10 trials. First, you would calculate the probability P of picking out a red block over a series of n independent trials. And you would assume that P is constant. Then the probability of obtaining R red blocks is computed as n factorial divided by R factorial, where R is the number of red blocks that you want to pick out, times n minus R factorial, where n is the number of trials, times the probability of picking a red block raised to the power of R, the number of red blocks that you're trying to pick out of the box, times Q, where Q is equal to 1 minus P, raised to the power of n minus R, where n, again, is the number of trials, and R is the number of red blocks that you're attempting to pick out of the bin. We'll also calculate the probability distribution of R, and this is called the binomial distribution. Let's again go back to the code where we had the factorial function, and let's create a second function called Bernoulli underscore probability. Now this function is going to take 3 parameters: n, the number of trials; R, the number of red blocks we want to pick out of the bin; and P, the probability of picking out a red block. Now if our n is greater than or equal to R, we are going to perform that calculation, which was the n factorial divided by R factorial times n minus R factorial times P, the probability of picking out the red block, raised to the power of R, times 1 minus P, raised to the power of n minus R. Otherwise, we'll set the probability equal to 0, and we'll return the probability. We're going to modify the main function since we wish to call the Bernoulli probability function. We'll prompt the user for the number of red blocks, we'll prompt the user for the number of blue blocks, and we'll calculate the probability of picking a red block as the number of red blocks divided by the sum of the number of red blocks plus the number of blue blocks. We'll prompt the user to input the number of trials, and we want to compute the binomial distribution. So for the number red, we're going to go from 0 all the way up to red blocks plus 1. Now we want to find out what is the probability of picking out some number of red blocks. So we're going to call the Bernoulli probability function, and we're going to pass in 3 arguments: the number of trials, the number of red blocks, and the probability of picking a red block. We'll then print out the probability of picking a specific number of red blocks over a given number of trials. Let's run this code. So I'm putting in 10 red blocks, 15 blue blocks. I'm going to say the number of trials will be 10. And then we'll see the probability of picking 0 red blocks and 10 trials, 1 red block, 2 red blocks, all the way up to 10 red blocks and 10 trials. And you can see with 11 red blocks, the probability is 0 because there's no way that we could pick 11 red blocks because there were only 10 red blocks in the bin. And this chart shows the data for the binomial distribution.
Go to www.learningiot.net for more information on where you can buy Learning IoT with Python and Raspberry Pi.